All right, advanced pre-calculus. Hello, hello. I'm going to make a video here for 6.2 due to all the absences we have going on. So hope this is something you find helpful. I'll probably go pretty fast, but that's okay because you can rewind and pause. Or if I'm not going too fast, you can speed it up. So we're going to start with 6.2, which is trig ratios here. And the unit circle. My notes from angular speed and linear speed kind of bled into this part here. So we're at 6.2 ratios and the unit circle. So there's 6 trig ratios we're going to start with. And you might be going, what? I thought there was only 3. Well, there's actually 6. So we're going to talk about that. We're going to talk about the unit circle, which is huge this year. Huge, huge. Something that you're going to just know and embrace and utilize quite often this year, next year, this unit circle. And so then we're going to use the TI to find trig values and then find trig values for any point in the plane. All right, so let's get started. I may chop this 6.2 into 2 videos, or I may just keep going. We'll just see how it goes for me here in R207. All right. Something new, the reciprocals of the basic trig ratios lead to 3 new ratios called secant, S-E-C-A-N-T, cosecant, C-O-S-E-C-A-N-T, and that's abbreviated C-S-C, and cotangent, C-O-T. Okay, so definition of the 6 trig ratios. Okay, so let's go to our right triangle over here. You've got a right angle, and if theta's here, great, or if theta's up here, great. You just have to figure out, the angle that you're looking at so that you can correctly identify the other sides. The hypotenuse never changes. It's always across from the right angle. And then if the theta is here, across from it, this is called opposite. And then this is adjacent. So theta is next to it, next to the side. Theta is also next to the hypotenuse, but the hypotenuse is always already wearing the hat of the hypotenuse. Okay? So if theta were up here, then this would be the opposite and this would be the adjacent. So these can flip-flop depending on the reference angle. Okay, so SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's that SOHCAHTOA. Okay, that's how it's universally sort of remembered that it's SOHCAHTOA. Now, when I was in your shoes, we just kind of had our calculators, not these. I did not have this when I was in your shoes. Just a scientific, but sine, cosine, and tangent are traditionally listed in this order on the calculator. So sine, cosine, tangent is sort of the natural progression. And we remembered it as, oh, how Andy hates old algebra. So whatever works for you to memorize it, it's really not that hard. It's kind of like the quadratic formula. It seems hard at first, but your brain's like programmed to know this, so it's pretty easy. Okay, so now the 3 new ones. So let's just start with tangent. Tangent goes with cotangent, so that makes sense. You got a tangent and you got a cotangent. And so when you're sort of pairing these, one will be the word and one will be the co-function. So tangent, cotangent, it makes a lot of sense, okay? And so the cotangent is going to be the reciprocal of this. So it's going to be A over O. All right? So cotangent is basically the reciprocal of tangent. It's 1 over tangent. So these 3 new ones are just the reciprocals. All right? And so sine and cosine, those kind of sound, verbally like they should go together, but they're the 3 main ones. So sine and cosine. Cosine is the co-function of sine, right? But but not in terms of reciprocals. I mean, that's a bit confusing, but again, this is pretty easy for most students. So we bring in this cosecant, secant. So sine, they each have to have a word and a co. So sine is just a word, and this is a co. And so sine goes with cosecant, and that's h over o. And so cosecant is 1 over sine. And cosine already has that co toward it, and it goes with secant, and that's h over a. So just reciprocals. And so secant is 1 over cosine. Sounds confusing right now, but you just have to just memorize it, and I promise you this isn't that hard. All right, so use your TI to find the following. Pay attention to your mode. We are in degrees right now. We've learned about radians, but right now we're in degrees. So the sine of 30, we're just going to plug that in. And, sine of 30 is going to be, just real quick, there's 30, there's 60, okay, 1, 2, and root 3. Sine of 30 is something you're going to know, 1/2. That's something you're going to know off the top of your head very soon. On your TI mode, it's in degrees, great. Sine of 30, 0.5, okay, 1/2. So there you go. So the cosecant of that is going to be 2 over 1. It's 1 over the sine of 30, which is 1 over 1/2, which is not a lot of room here. 1 times 2 over 1, which is 2. Okay, so that's how you're going to compute these. So when I do the secant of 72, I'm going to do 1 over, so who's its reciprocal? Secant needs a co, so it's going to go to cosine, 1 over cosine of 72. All right, so make sure you don't mistake this cosine to the -1. That doesn't mean, oh, that means 1 over cosine, which is secant. That -1 with functions does not mean, hey, I'm in the wrong place, move me down. When that -1 is on a function, like on an idea, it means inverse. So this is cosine inverse. This is not 1 over cosine, which is secant at all. You'll see that sine, cosine, and tangent are here, but cosecant, secant, and cotangent, they're not on the calculator. The calculator wants you to know it's a reciprocal, and that's what you have to do. So for this particular problem, I have to go 1 over cosine of 72. Okay? And you get that this is, you get the number here, which is 1 over cosine of 72, which is 3.236. All right. Moving right along here, let's go to secant squared of 50 minus tan squared of 50. Okay. So secant goes with, again, cosine. And then tangent is just tangent. All right, so this might be sort of confusing to you looking at this. This squared is the same thing as secant 50 degrees quantity squared. And this tangent 50 degrees quantity squared. Okay, so this is confusing. So this new notation is brought in because students, you don't want to do the secant of 50 squared. You want to do the secant of 50 quantity squared. And you don't want to do tangent of 50 squared. You want to do the tangent of 50 quantity squared. And so when the square is, in parentheses and all that kind of stuff, it gets confusing and students tend to miss. So the notation, the square on this whole secant of 50, notationally we put it right here just so it's very clear what is being squared. Secant of 50 is being squared, not 50 is being squared. Okay, so that's probably new for us. And so we're just going to, reciprocate secant and move forward. Okay, so this is 1 divided by, now your calculator doesn't have this notation. So that's important to note. Your calculator can't put that there. So you are going to be really careful here. You want to do the quantity square. So cosine of 50, close that parenthesis. Let me get it where you can see it. So you want to square the whole thing. So I'll put a parenthesis here. Cosine of 50, close that parenthesis, close the denominator parenthesis, and then square that. All right, so this is, 2.420, and then tan squared of 50, same thing. So you want to do tangent, actually I want to do parentheses because I want to square the whole thing, tangent 50, close that, and then close the squaring, quantity squared. All right, so that's 1.420. And I would probably do this if I were doing this problem on a test or something. I would just do 1 divided by parentheses cosine 72, 50. This is 50. 50, close that parenthesis, squared, minus. Now the calculator knows to pop up. It knows that we're done. Oops. Let's divide. There we go. The calculator knows that once you close this parentheses that you're done in the denominator, and it's going to pop us right back up to the numerator. So you don't, it kind of understands that order of operations. Anyway, so this is tangent 50, close that, squared. All right, and so that comes out to 1. That's how I would probably put it in the calculator, okay? So there's that, but in the calculator. And 1. All right. Okay, so exact values of these trig functions. This is going to be your verbal quiz number 2. Some call-outs here. Notice that the chart's a little bigger because we've included the new trig functions. All right, so we have sine, cosine, tangent, cosecant, secant, and cotangent. Over to the right here, let's show that. Got 2 little triangles. These are your special triangles. So in radians, and we're transitioning to radians, 30 degrees. All right, what in the world does 30 degrees, mean to us in radians? So 30 degrees. Ooh, I need to get my nails redone. Look at that. Oh well. Okay, so 30 degrees here. So 30 degrees in radians is pi over 180. Okay, so it's pi over 6. 30 degree angle, pi over 6, folks, know it. 45, pi over 180, pi over 4. 45 degree angles, pi over 4. Know that. And 60 degrees, convert, pi over 3. I promise you, by the end of the year, you'll be thinking in terms of radians, not degrees. But you can always think in terms of degrees if you need to. Okay, so let's start with our 30 degree angle. And then we'll do our 45 and then our 60. Okay, so, the 6 and 3. So just remember pi over 6 is your 30 degree angle. Pi over 3 is your 60 degree angle. Okay, so this is your 45. So let's do pi over 4. Pi over 4, special right triangles. What's the ratio? 1, 1, root 2. So let's do this one. This is easy. So either reference angle, same result, 1 over root 2 when rationalized, root 2 over 2, root 2 over 2, okay? And then whichever one you're looking at, 1 over 1, boom. Easy to reciprocate 1, okay? And then I'm going to look at the reciprocal here. So remember, this has been rationalized. So when I'm here and I do 1 over root 2, that's been rationalized to root 2 over 2. So when I reciprocate this, unrationalized, if you will, it's just root 2 over 1. So this is just root 2, same because the angles are the same. 45 degree angles are super easy. Okay, so let's go here. This is a smaller angle, so this is your 30 degree angle. This is pi over 6. This is pi over 3. This is your, looks like your bigger angle. Doesn't really matter. It's just so long as everything's labeled. Okay, so across from the smaller angle, which is going to be our pi over 3. pi over 6 up here. This is your pi over 6. This is your smaller angle. This is 1. And then the hypotenuse is 2, and this is that root 3. Okay, so let's get this chart filled in. Can you see that? Oops. This way. Okay, so 30-degree angle, 1/2. Okay, root 3 over 2. And I want to talk about tangent in just a minute. Okay, so let's go to this angle, the 60-degree angle. Okay, so the sine here is going to be root 3 over 2. Cosine is going to be 1/2. Okay, so right here, so cosine is 1/2. All right. And now I want to talk about tangent, and then we'll reciprocate them. Okay, so the easiest way to remember tangent in radians, and this is a shortcut that is universally used. So let's look at pi over 3 first. Okay, so let's look at pi over 3. So the tangent of pi over 3 here is going to be opposite over adjacent, and that's just root 3. So the shortcut is to see in radians that that's just a 3 and that's just a 3. So 3, root 3. If you were to do pi over 6, you would be doing 1 over root 3. So tangent of pi over 6 is 1 over root 3. When rationalized, you get root 3 over 3. And so the way to memorize that quickly is this is a 6, and that's 3 plus 3. Mathematically, that doesn't make any sense. This is a shortcut. It's a trick to help you memorize it. So in radians, when you see the 6 for tangent, root 3 over 3. When you see the over 3, just root 3. Okay, so there's that. All right, so now let's reciprocate all of these. Okay, so this reciprocal is easy, 2, which means this reciprocal is easy, 2. All right, and let's see, let's go to here. Let's reciprocate this one. Okay, so when we're looking at the secant of pi over 6, so let's go to pi over 6. And let's do the secant. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So let's just write that out. So if I do the secant of pi over 6, I am 2 over root 3. So when rationalized, that is 2 root 3 over 3. Okay? So that's 2 root 3 over 3. Okay, that's probably your hardest one to kind of memorize or get your head around. But it's just that reciprocated and rationalized. So that's going to come into play right here also. All right. So that will do the same for cosecant of pi over 3. So cosecant of pi over 3 would be 2 over root 3. Same thing. Okay, so 2 root 3 over 3. All right, so now let's go to this reciprocal, okay? And then, or you even could just go to pi over 6 right here, and instead of doing 1 over root 3, this would just be root 3 over 1. So with cotangent, you could sort of the trick, you could think the opposite. So this is 6. Tangent will be the one that involves the 2 3's. Cotangent will just be the one that involves the 3. And then same thing here. Pi over root 3, the cotangent is going to be 1 over root 3 when rationalized will be root 3 over 3. So you could think with my trick, with tangent, that's just root 3. With cotangent, it'll be the other option. So that is going to be your verbal quiz number 2. Okay, next page. We have defined the 6 trig ratios in terms of an acute angle in a right triangle. This means we can only find trig ratios for angles between 0 and pi over 2, which is 90. See, we're talking in radians now. Okay, so we got to extend this. So let theta be an angle in standard position, and let xy be any point on the terminal side. Okay, so here's standard position. Here's the initial side, and here's the terminal side. All right. Let r be the distance from P to the origin, so kind of like a radius. All right, and so if you were to compute r here, you would say, okay, so r is, if I drop this perpendicular down, this would be over x and up y. So if I were to talk about r here, r would be the square root of x squared plus y squared. Wait a minute, Mrs. Muller, how did you get that? What happened there? Well, Pythag, x squared plus y squared equals r squared. So x squared plus y squared equals r. Okay. So let's look at this. So if we look at theta in standard position in terms of coordinate plane coordinates or ordinates, the sign here is going to be, let's see, y over r. Okay, so that's the y value over r. And cosine is going to be the x value over r. And then tangent is going to be the y value over the x value. Okay, so this is going to be super important when we lock this down to the unit circle. Okay, because radius is just going to be 1. So we're going to develop the fact that the sine, on the unit circle, sine is the y value, cosine is the x value, and tangent is really then just sine. T here, really this should say theta. That's a little mistake in the notes. All right, theta. So tangent is just going to end up being the sine of theta over the cosine of theta. And that's with the unit circle with R1. Okay. So, cosecant then is going to end up being this r over y. R over x. And x over y, or cosine over sine. Okay, but that does depend on the unit circle and r being 1. So this is just kind of food for thought here, because we're not always going to have it with r being 1. But when it is the unit circle, we're going to see that sine is just y, cosine is just x, and tangent is y over x. Or, in the future here, sine over cosine. Okay, but let's just get back to the notes. As theta increases, okay, point P can lie in quadrants 1, 2, 3, or 4. So this means the trig values can be positive or negative, because if we're in quad 2, x is negative. If we're in quad 3, x and y are negative. And if we're in quad 4, y is negative. So trig values are about to start changing signs here, okay? So let's look at some easy examples just to kind of get us started here on this new idea. All right, so we're going to find sine, cosine, and tangent of the angle theta whose terminal side passes through the following points. 2, 5, quadrant 1, negative 2, 5, quadrant 2, and then quadrant 3. All right, so you'll just see how, this is pretty basic, you'll just see how they switch signs here. Okay, so 2, 5 is 1, 2, 1, 2, 3, 4, 5. So this is not unit circle stuff. This is just random points and angles and such. So there's an angle. All All right, and so we're going to find the sine, cosine, and tangent of the angle theta whose terminal side passes through the following points. All right, so we're going to drop a perpendicular and make this angle here. We'll put theta here. Okay, so this side is 2, this side is 5, and we need to find the hypotenuse. So 2 squared plus 5 squared is this radius squared. 4 plus 25 is radius squared. 29, and let's just go ahead and square root that. So root 29. So sine, cosine, tangent. All right, so sine theta, cosine theta, tan theta. So theta is right here at the origin. 5 over root 29, 2 over root 29, 5 over 2. Okay, so I'm not going to rationalize here just for the sake of going for the idea versus just the simplified version. So we're just going to leave it unrationalized. That's okay. That's what we're going to do right now. Okay, so now we're going to go negative 2, 5. Always drop your triangle down to the x-axis. That's hugely important. You always reference down to the x-axis. So now this is 2, 5, and then again we have this root 29. And so math teachers or mathematicians or math heads, whatever you want to say, they'll battle with this. So some people just cannot label a side of a triangle negative 2 because it's a side of a geometric figure. And then others want to label it negative 2 because on the coordinate plane it is negative 2. You choose what you subscribe to, okay? I feel like if I put a negative, I get both ways. So I don't really like to label this negative 2 because it is the side of a triangle, so that's just weird. But if I focus on the coordinate plane and write negative 2, then I can sleep at night. And if that negative's there, then I probably won't miss my sign when I do the ratios. But in a bit, we're going to learn what trig ratios are positive in what quadrant, and then you could just label that 2 and then just know who you need to make negative where. Okay. But right now, I'm going to label it negative 2. All right, so sine of theta, cosine of theta, tan of theta. All right. So sine is going to be 5 over root 29. So in quadrant 2, you guys, sine's positive. Cosine is going to be, so remember theta is right here at the origin, negative 2 over root 29. And tangent then is negative 5 over 2. Or 5 over negative 2, but negative 5 over 2. So, quad 2, sine is positive. All right, next one, let's go into quad 3. So point 2, 1, 2, 3, 4, 5, right here. Okay, and always lock it down to that x-axis. A little bit off there. Right to that x-axis. Theta, so negative 2, negative 5. Right angles right there, always with the x-axis. Okay, so sine theta, cosine theta, tan theta. All right. Again, this is root 29. Okay, so sine of theta then is going to be negative root 5 over 29. Cosine's going to be negative 2 over... Sorry. I've made like 8 videos today, so forgive my mistakes. This is negative 5 over root 29, and this is negative 2 over root 29. And then tangent of theta is going to be negative 5 over negative 2, which is going to be 5 over 2. So note, Q3, tan of theta is positive. This is going to be something we're going to memorize when it comes to the signs of trig functions in particular quadrants. All right, so I got a bit ahead of myself before, but right now this is going to solidify on the unit circle exactly what sine and cosine, sine of theta, cosine of theta, and tangent mean. All right, so we're going to restrict. This up here was not restricted to the unit circle. This is just kind of, oh, no, here. This was just in general. But we're going to be focusing on the unit circle, really, for the most part, after we get through this kind of 6.1 to 6.3 section. But if we restrict the points xy to the points on the unit circle, then radius is 1. What is true about the coordinates of P? Well, the cosine, let's see, so let's go here. Here's T, this is angle T. Other page it was theta, now it's angle T, so that's T. Standard position is x-axis, there we go. There's xy, okay? And so if I go here and drop a perpendicular, this is x, this is y. All right, so the cosine of T is x over 1, okay? Strictly because our radius on the unit circle is 1. So I got a little glitchy there. Our radius on the unit circle is 1. So radius, 1, however you draw it. The triangle perpendicular comes in here, but this radius is 1. All right, so cosine is adjacent over 1. Which is just x. Okay? So I don't know what this box is doing here. Okay. So cosine is just x over r, which is 1. So cosine on the unit circle, very important that this is on the unit circle, don't over apply it, is the same. The x here is the same thing as cosine of that angle. This is really, really important. Sine is y over 1 or y over r, but for unit circle that's y over 1. So the sine of t is just equal to y. Okay? So if you're to label a point xy, you could also label that point cosine of this angle at the origin, sine of t, which is that angle at the origin. And then tangent is just y over x, which is y over x, sine of t over cosine of t. No, 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 this. All right. So conclusion on this page, and we'll get over to some more fun stuff. For any real number, t, so t, there's a unique point for any angle on the unit circle. There's a unique point on the unit circle. It has to be the unit circle. Radius is 1, such that the point xy is the same as the point cosine t sine t. Or cosine of t is the x-coordinate, sine of t is the y-coordinate, and tangent is then sine of t over cosine of t. All right. So that formula is a star for that. Okay, let's move over to the next page. All right, this is the single most important thing you will learn this semester. Muy importante, the unit circle. Here it is. You're going to know this. You're going to live, love, and breathe this. Okay, the unit circle. All right. Let's start. You can determine the sign, positive or negative, of the 6 trig functions based on the unit circle. Okay? So, here, this is x, y. Okay? It's quadrant 1. Quadrant 2, negative x, positive y. Quadrant 2. Here, negative x, negative y, and here, x, negative y. Okay, so let's think about this. If we're in quadrant 1, sine is x, positive, cosine is y. No, sorry. Cosine is x, sine is y, all positive, tangent is y over x, all positive. So everybody is positive in quadrant 1. All right, yay. Everybody is positive in quadrant 1. Okay, this is quadrant 1. In quadrant 2, okay, so cosine is x, so cosine's negative, sine is y, sine's positive, and tangent is y over x. So that's a positive over a negative, so tangent's negative. So who is positive in quadrant 2? Sine is positive. I'll call it there. Well, we'll just say sine in general. I really don't like to leave that bald, but we'll just say sine is positive. All right, in quadrant 3. In quadrant 3, cosine is negative, sine is negative, cosine is negative, sine is negative. Tangent is sine over cosine, that's negative over negative. Tan is positive, okay? So tan is positive in quad 3. And then in quad 4, cosine is positive, sine is negative, and tangent is negative over a positive, which is negative. So cosine is positive in quad 4. Okay, so everybody's positive in quadrant 1. All 6 of the trig functions are positive in quadrant 1. Sine is positive in quadrant 2. That means sine's reciprocal, which is cosecant, is also positive in quadrant 2. Everybody else is negative. In quadrant 3, tangent's positive, cotangent is positive, it's reciprocal. Everybody else is negative. In cosine is positive in quadrant 4, as well as secant, it's reciprocal. Everybody else is negative. I hope I said all that right. Okay, so there you go. There's a simple way that is something that can help you kind of remember this. All students take calculus. All right? So everybody's positive, sine is positive, tangent's positive, cosine's positive. And you just have to remember alts as well as their reciprocal functions. All students take calculus, and it goes as the way as the quadrants go. Okay, so the following are possible questions on an oral quiz, a verbal quiz. Be sure to answer by looking at your circle. So in what quadrants is the sign positive? Well, everybody's positive in quadrant 1, and sine is positive in quadrant 2. In what quadrants is the sign negative? Well, that would be 3 and 4. Okay? Remember, sine is the y value, so that would be below the x-axis. What quadrants is cosine positive? That would be 1 and 4. Remember, cosine is the x value on the unit circle. That's 1 and 4, so that's where I'm right. And where's cosine negative? Well, it would be left, and that's 2 and 3. Okay? What quadrants is tangent positive? Okay, well, everybody's in blend, and then, tangent's going to be either a plus plus or a minus minus, so that's 3. And then where's tangent negative? That would be 2 and 4. More interesting here are these questions. In what quadrant are the sine positive and the cosine negative? Okay, well, sine is positive in 1 and 2, and cosine's negative, so cosine is going to be positive in 1. So this has got to be quadrant 2, right? So positive in 1 and 2, and then cosine is negative in 2 and 3. So where's the overlap there? That's got to be quadrant 2. In what quadrant are both the sine and the tangent negative. Okay, well, sine is negative in 3 and 4, and tangent is negative in 2 and 4. So, where's the overlap? This is 4. Okay, so that's kind of fun. Fun stuff there. Okay, exact values of trig functions. We're going to go through, we're going to add in these quadrantal angles, okay? So exact values of trig functions. So we've discovered that any point xy can be written as cosine sine, where t is the angle in standard position. We can now find the following quadrantal. Angles in radian measure. Again, this is on the unit circle. Okay, unit circle. All right, so 0 is 0 radians, pi over 2. I mean, really, we should go 0, and then this is 2 pi. That's just the circumference of a circle, which is 2 pi r, 2 pi 1. Half of that, and then 3 pi over 2. Okay, this is 0, 2 pi, with pi over 2, pi, 3 pi over 2. Okay, so this would be the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. So quadrantal angles are ones on the x, y, axes. The ones that are right at that 90-degree mark, or 180 mark, or 270, so on and so forth. Okay, so this is kind of easy. So sine on the unit circle is the y value. Cosine is the x value. Tangent is sine over cosine. Start there. Let's go pi over 2, pi, 3 pi over 2, and 2 pi. Well, 2 pi, these guys are just cyclical. So they're the same. That's easy. They're just a repeat. Okay, so let's go up to pi over 2. So sine is 1, cosine is 0. And tan is sine over cosine. That's 1 over 0. This is undefined. The tangent is not defined at pi over 2. All right, sine here is 0. Cosine's negative 1. Tangent is 0. And then at 3 pi over 2, sine is negative 1, cosine is 0, and this is negative 1 over 0, undefined. Okay, so now we're just going to reciprocate all of these. Let's reciprocate 0, undefined. Let's reciprocate 1, and let's reciprocate 0, undefined. So on and so forth. 1, undefined. And then how do we reciprocate undefined? Well, instead of 1 over 0, it would be 0 over 1, so this is 0. Okay? Reciprocate, undefined. Reciprocate negative 1, reciprocate undefined. Reciprocate negative 1. Reciprocate undefined. Reciprocate undefined, 0. Reciprocate undefined. Reciprocate 1. Reciprocate 0. Those are your quadrantal, so the measures on those perfect right angles as you go around the unit circle. All right, definition of a reference angle. Here we go. This is important. Basically, pretty simple. Always lock the angle down to the x-axis. We just kind of pretend it's an acute regardless of the quadrant, and pretend it is in quadrant 1, basically. So we're going to lock it down to the x-axis to do that. So let's draw it out before I talk anymore, because it'll make more sense when I draw it out. So given an angle T in standard position, the reference angle T prime is the positive acute angle formed by the terminal side and the x-axis. By the terminal side of T and the x-axis. All right, so if you're in quadrant 1, it's pretty easy. So it's just T is the same thing as T prime. If we get into quadrant 2, there's T. If we get into quadrant 3, there's T. And if we get into quadrant 4, there's T. But the reference angle, the one you want to deal with to assess your 6 trig functions, lock it down to the x-axis. So T prime is right here. Here, you're going to use this angle, T prime. I know that feels weird, but that's what we're doing. Here, we're going to use this angle, use the positive acute angle formed by the terminal side of T and the x-axis. So this will be T prime right here. And in this situation, T prime will be right here. Okay. So sketch the angle and find its reference angle. Use color to draw the reference angle on your sketch. Okay, so 3 pi over 4. Here we go. All right, so 3 pi over 4. So this is pi over 2. So here we go. We're moving. Right here would be pi over 4, 45 degrees, if you will. And then here, that's 2 pi over 4, so pi over 2. And then 3 pi over 4 is here. So to assess the trig functions on a 3 pi over 4, we're going to use this angle right here, which is a pi over 4. Okay, so note the 3 pi over 4 and this reference angle, T prime, that makes 4 pi over 4, which is just pi, which is just this 180 degree line. Okay, so we will base our trig functions off pi over 4 for 3 pi over 4, and we'll know we're in quad 2, so everybody will be negative except for sine and cosecant. That's the thought process. All right, 5 pi over 3. Okay, so 5 pi over 3. So, you know, if you want to do a quick kind of thought as we get moving here on what this is, you know, if you were to do a quick conversion, 5 pi over 3. Okay, you're going to be looking at a 300 degree angle. Okay, so 3 goes into 180, 60 times 5 is like 300. Okay, so 5 pi over 3. We're going to be going like this. Okay, so that's your angle. But our reference angle is right here. Okay, so the reference angle here, so, you know, pi over 3 is like a 60 degree. And so, to get all the way over here, you know, 5 of those leaves me with 160 degree angle right here. So right here is pi over 3. And you can think about 5 pi over 3 plus additional pi over 3 gets me to 6 pi over 3, which is this 2 pi mark. Like this was the pi mark. Okay, so your reference angle here is going to be pi over 3. So T prime here is pi over 3. So we'll base all of our trig functions off a pi over 3 or a 60 degree angle in quad 4. So everybody will be negative except for cosine and secant. All right, so there's that one. And so if you think about mathematically what's happening here with these t primes. So this one, I took pi and went kind of backwards from that. So to compute, if you're in quad 2, to get here, I could have easily just done this pi, right here, this 180. Okay, this 180. If you're in quad 2, you can take this pi and minus 3 pi over 4. Okay, and so common denominator, 4 pi over 4, pi over 4. And so here, notice we were at 2 pi, and we dropped down. So this ending result is 2 pi, and minus that off. So we could have done 2 pi minus 5 pi over 3. Common denominator then is 6 pi over 3. So that reference angle is pi over 3. So we're going to be, developing this, that if you're in quad 2, to find the reference angle, subtract from pi. If you're in quad 4, to find the reference angle, subtract from 2 pi. Okay, so there's that. So now 7 pi over 6. Let's think about 7 pi over 6. Again, we're still pretty early in this, so 7 pi over 6, if you want to do a quick conversion. All right, so 180 over pi, cancel, cancel. That's 3, that's 210. All right, so that's going to be here. All right, and so our reference angle now is going to be this. Okay, our reference angle now is going to be this. So this we went from pi and backed it up. From this we went 2 pi and backed it up. But here we're going, to do pi, and we're going to go kind of forward past pi.